Hello folks. Today I'd like to talk about chemical physical changes and properties, with our goal being to identify chemical and physical changes and their properties and be able to differentiate between the two. Now, let's first start with talking about chemical and physical properties. A physical property is a property of a substance that can be observed without changing its composition. So, for example, if I look at the color of a particular compound or element like iron, I don't have to change that substance in order to observe its color. I can just see that it has a color. And so color is an example of a physical property. Density would be another one. We can measure the density of an object without changing its properties. And so density is a physical property as well. Some other common ones that you're going to find are odor, boiling point, and melting point. Anything that involves observing a chemical but not changing whatever that substance is. On the other hand, a chemical property does change that substance's composition. So it's a property of a substance that changes its composition when observed. Now, these are a little harder to think of at first, but once you start seeing the idea, you're going to realize that every one of these is just something undergoing a chemical reaction. For example, flammability is a chemical property of a substance. Not every substance is flammable, at least under most conditions, but some substances are, such as paper, wood, things like that. And so that's a chemical property that's shared by wood and paper. Similarly, reaction with acid would be a chemical property of some substances. Not every substance is going to react with certain acids, but some will, and so we would classify that as a chemical property. Now, how this is useful is we can then talk about things changing and whether that change is actually changing its substance or is it just preserving that substance and moving it to a different form. So for example, let's take our boiling water here. So we have water boiling over a flame. That water is forming those bubbles in there. We would call those steam, and that steam is rising to the top. Is that steam still the same substance as the liquid water in the bowl? Well, of course it is. It's just water in a different form. It's going from a liquid to a gas. So a physical change, similar to a physical property, changes a substance's form. So one example of that being any phase change. Whether it's freezing, melting, boiling, condensing, any of those changes are going to involve a physical property. In this case, we're observing the water's boiling point. So a physical property accompanies a physical change. On the other hand, you have changes like this. This is a strip of magnesium that is burning in oxygen. This is showing the magnesium's flammability. It's with a little bit of activation energy, it can burn with this brilliant bright flame. We had to change the magnesium to do that. We don't have magnesium afterward. Once you've burned it, that magnesium has changed form. And so a chemical change involves, it actually changes the chemical substance to a different form or a different substance. So an example of that would be burning. We no longer have the substance that we had before. Now, how this is useful involves talking about mixtures. So if we have a mixture of two different compounds, let's say, or elements in this case, let's say iron and gold, we could separate those using their different properties. For example, a very simple one is if these were chunks of iron and gold in our laboratory, we could pick out the gold from the iron. We can do that based on its color. That physical property of color would help us separate the gold from the iron. Another way we could do that would be using magnetism. We know iron can be magnetic, iron filings, and so if we used a magnet, we could separate that iron from the gold, because gold, as we'll learn later in this course, is not going to be magnetic in this form, and so it would be easy to separate using those physical properties. Now, you could come up with chemical properties to separate them as well. Gold is very unreactive as a metal. It won't react with most acids, but iron will. So if we added a particular acid to this that the gold wouldn't react to, we could actually dissolve the iron, separate out that iron and acid mixture, and we'd be left behind with just gold. And so mixture separations can use chemical or physical properties. And there are many, many examples of these that we're going to see throughout our course. Some good examples are things like filtration, distillation, and chromatography. Filtration separates substances based on their size. If we have a porous piece of filter paper with holes that only allow certain sizes through, we can pass some substances through the filter paper, but have some remain behind. Distillation separates by boiling point. And then chromatography separates based on substances' adhesion to different materials, whether they want to stick with one material or move on from that material. Okay, that's been all about chemical and physical changes. Thank you all. Have a nice one.